way, so.
So howdy, so welcome to Bash number 2. We are, hopefully we're not starting early. So tonight, Gareth Gilmore is going to be giving us his view on functional programming. I'd like to feel that this is a relatively informal environment, so if anybody's got any questions, feel free to ask during or after. And with that, Gareth.
Thank you.
Everyone.
Thank you very much. True story, I was walking out the door about 2 hours ago and my wife looked me up and down and she said, "Are you going out like that?" I said, "Oh yeah, we're very determined to make sure Bash doesn't look corporate in any way." And she went, "Well, congratulations." So this is fairly non-corporate, I think. So try and keep tonight as relaxed as possible, so please throw questions out as they occur to you. As always, I reserve the right to kind of defer them until the end, allegedly because they take up too much time, in reality probably because you've just scared me, okay? So we'll see how it goes. So just trying to set the tone for the evening here, ripping off Law and Order, of course, So I would like to say right at the very beginning, I am not an expert in functional programming. Functional programming has been around for at least 30 years in the academia, and it's slowly beginning to make its way back into mainstream programming again, one little bit at a time, okay? And for the past 4 or 5 years, I've just been trying to educate myself, one little bit at a time, as you do, So what I'm trying to do here is lay out a kind of roadmap, of the stuff that I've learned so far. And as it turns out, my association with functional programming goes back a long way, and I didn't actually know this until I started preparing this talk, because my first degree wasn't in IT, it was actually in philosophy and psychology. And if you think that's easy, imagine having 6 hours to write a paper on one question, sample question being, do flowers feel? Discuss. I was doing philosophy and psychology. I was living with a whole pile of people doing computer science, and something I was hearing from them an awful lot was, "Oh, bloody Miranda," So of course, eventually I asked who Miranda was, and learned that Miranda is actually a language, So what was going on was all the first years doing computer science. They were being forced to write all their assignments and so on in this particular language. And the reason they all believed was that because the professors didn't want to program in C. Because they knew that there had been all these kids who'd have spent their summer learning to program in C and do Space Invaders or whatever. And they didn't want to get shown up. So they deliberately chosen this weird academic language just to slow everybody down like a sea anchor. So this was back in 1990, that's when I was an undergrad. So this is Miranda, which, as I learned whilst preparing for this talk, was functional language written back in 1983. So functional programming has been around for a long, long time. So what I'm going to try and do tonight is just give you a little overview, try and prepare the way, and talk about some of the stuff that's been interesting me recently, and hopefully it'll be interesting to you as well. So I'm a fan. I enjoy functional programming. I'm not entirely sure about functional programmers. If you go out in the news groups and listen to some of the stuff that people are saying, it can be very annoying, kind of makes your fists itch, So you kind of listen to some of the functional programming community talking and you're going, my God, that's amazing. You're saying I should carefully manage state, and here I was creating 50 gig text files in my get salary method of employee, but you're showing me a better way. And you say you've got this better thing than looping called recursion. Oh, never heard of that before. So, no, some people in the FP community, I think they push it a little bit too far. You hear things like, damn, we could easily rewrite all of enterprise Java in just 40 lines of Haskell. Maybe not. So, hopefully, I'm going to say a few things that will annoy some FP purists. Any functional programming purists amongst us? Anybody want to be brave? Hey, well done. Good man. Excellent. I see you've got a wine glass. I'm slightly worried about that. If you could switch the wine glass for something that bounces, that would be great. So yeah, so please throw out any objections or anything I've got wrong and so on. So you kind of get this dialogue going on at the minute where your FP guy says, don't program in Java, and you say, why not? And they say, it's restrictive, the world isn't made up of objects, the old philosophy, it doesn't properly model the world and so on. And you say, okay, well, what should I be using? And they go, use Lisp. Why? Well, Lisp is wonderful, everything's a list. Oh, that's not restrictive at all then, And then they say, oh no, it's great, better yet, these days, you should really be using Haskell. Why? Well, Haskell's completely side effect free. It means you can't do anything in your functions apart from pure math. Brilliant, So, of course, that's not restrictive at all. So, whenever they say that, with functional programming you can be a lot more free, they do seem to mean free in the sense of the world's major religions, So, it's a particular sense of freedom, But we'll get into that as we go along. So, there's lots of good stuff in functional programming, but if you were to boil down everything I ever learned about IT just to one phrase, I think it would be it's all about bags of pain. You pick whichever bag of pain you're most comfortable with. Okay, so OO programming is one particular bag of pain. Yeah, functional programming is a different bag of pain. Yeah, anybody familiar with the African myth of the Tree of Sorrows? Anybody heard that one before? No. At the end of time, we're all dead, and we go to this big tree with our sorrows, and you hang your sorrows up in a branch, yeah, and everybody gets to walk around the tree, and you can pick anybody else's bag of sorrows that you want. And the idea is that at the end, you come back and you pick up your own again, and everybody's the wiser and so on. So in IT, it's often about bags of pain, and we're familiar, very, very familiar, with our particular bag of pain, which is OO programming. But there's this other bag of pain, which is functional programming, and at the moment everybody's doing, oh, nice, different, But different doesn't necessarily mean better. Might do, might not, we'll see as we go along. So while I'm doing the introduction, for people who've done a little bit of FP before, here's a little quiz for you. So I'll describe this for the back row. I know it's a little bit hard to see at the back. But let's say you've got an HTML page. On the HTML page, you've got a form. Inside the form, you've got paragraphs. Yeah? Every paragraph has a label, let's say inside a span tag, and then some kind of form input. Let's just say a text box. Okay? And what you need to do in JavaScript or something like that is get this kind of behavior here. So if somebody tries to submit the form and some of the fields haven't been filled out, then you're going to display an error. But you're going to display an error by changing the associated label. Okay, so that's what makes it a little bit interesting. Okay, so remember, for each form input, there's a label, in a span, and what you want to do is, if the input is invalid, let's just say there's nothing in it, then you want to find the associated label and turn it red, something like that. Okay, so a little quiz. How would you do that? And for those of you that have done FP before, how would you do it in a functional way? Okay, can you get the idea? So we'll come back to that in just a wee minute. So here are some functional languages. We'll be mentioning these as we go along. Just out of curiosity, who's tried any of these? So anybody tried any Scala? Yep, about 5 or 6. Anybody tried any Clojure? Yep, again, same number. Anybody tried any F#? Yeah, just 1 or 2, sorry. Yeah. Anybody tried any Haskell? Yeah, 3, 4, very good. Anybody tried any Erlang? 2, yeah, very good. So a smattering of people have tried all of those. So there are a variety of different functional programming languages around at the minute that you can play with, and we'll be talking about all of them as we go along. And you can classify them in terms of purity. So if you really want to, you can call JavaScript a functional programming language. It has all the capabilities in it to let you do functional programming. It has all the capabilities in it to let you do a whole pile of other kinds of programming as well. So from a FP point of view, you can consider it as being a very, very dirty language. And then it goes all the way up to Haskell, in terms of purity. Haskell was designed as a research language, but people are using it for real-world things these days. Yeah, and it's as pure as a functional programming language can be, on this planet anyway. Yeah. So you've all heard the discussion, of course, that Java isn't an object-oriented language; it's a mostly OO language. If you want real OO, go to Smalltalk and that kind of thing. Yeah. So Haskell fits that niche. Whenever you're doing Haskell, you're really, really doing functional programming. And then all the other ones that we'll be talking about, well, they sit somewhere in between. Okay. So, as you know, we're at the moment moving into an era of mixed language programming. So, whenever I first started programming in Anger, back in the 90s, you had a lot of languages, but as long as they were accessible from C, everybody was happy. Okay, so you were working in a company and you said, hey, I think this can best be done in Delphi, so I'm going to write this code up and compile it to a Delphi DLL. And people kind of looked at you, but then somebody said, but will you be able to call into it from C? Yes, that's fine. As long as you can call into it from C, everybody's happy. Yeah. So C was kind of the USB, and there are all these other languages around it. And then for a while, you were doing Java, or you were doing C#, or you were doing C++, and that's pretty much it. Yeah. But now, in the 2010s, we've got a whole pile of other different options as well. Yeah. And we're back to the same situation we were in before, though. It's can you talk to it from Java? In other words, I want to do this in Scala. I want to do this in Groovy. I want to do this in Clojure. Yeah. Well, can you talk to it from Java? Yes. Fair enough. And same thing in the .NET community. So, as you know, you've got the CLR, the Microsoft Virtual Machine, and it was designed from the beginning for interoperability, and that's a huge big help. Yeah. So, you've got PowerShell out there. I should have asked anybody use PowerShell? Yay, PowerShell, really nice. Yeah. So you've got a wide choice of existing languages, yeah, and then they've started adding on some functional ones. So you've got F#, yeah. You've also got PowerShell, which lets you do functional stuff. And then, not to be forgotten, you've got JavaScript. So people are increasingly describing JavaScript as the assembly language of the web, yeah? Simply because JavaScript is the one thing, as you know, that's guaranteed to be available in the browser, yeah? But we don't want to write raw JavaScript in case we inadvertently create global variables and we don't have namespaces, and all that kind of thing. So increasingly, there's a number of languages out there that compile into JavaScript. Yeah. So again, you can say, look, this is best done in Dart, or this is best done in Clojure script, or this is best done in CoffeeScript, and people look at you and go, yeah, it's okay. It compiles into JavaScript, when everybody relaxes. Yeah. So you've got these three different environments out there. Yeah. And in each of these environments, you've got a functional alternative. Yeah. So in the Java space, you can be doing Scala or Clojure. In the .NET space, you can be doing C# or F#. C# has lots of functional stuff in it. We'll come to that in a minute. And in the JavaScript world, you can be doing Clojure script or CoffeeScript or a couple of other ones as well. Great. And another thing that's fueling this is Java 7. Yeah? When Java 7 got released, I had to work really hard to restrain my indifference. I don't know about you guys. Yeah? Anybody else? Anybody really hyped up about Java 7? Yep, fair enough. Yeah. So, as you know, Java 7, I like to think of it as the Windows Vista of Java. An awful lot got promised, very little actually turned up. Yeah, so in the beginning, people were talking about closures, of course, and super packages, and Jigsaw, and XML literals, and all that kind of stuff. And not that much made it in the end. So for every other version of Java, been playing with it in advance, have courseware in it advance, in advance, all that kind of thing. With Java 7, everybody seems to be going, So Java as a language has reached the point that all languages reach, which is that you can't really bolt on anything too new without breaking something that's already there. Yeah, and Sun, now Oracle, as you know, are absolutely paranoid about breaking anything that's already there. For a really good reason. Yeah, so that's another thing that's prompting people to be interested in these new languages. Yeah. So just before we jump in and start looking at all this functional goodness, just to inject a little note of dissent, Miyamoto Musashi. Anybody know who this is? Yeah, a couple of people, good. One of the most famous swordsmen of feudal Japan. Yeah, therefore his place in this talk is obvious. You know. The reason why he's in is one of his claims to fame is that he fought all his duels with a wooden practice sword. Yeah, he got so good that he would wander around Japan practicing, and if somebody wanted a practice duel, that would be fine. He'd use his wooden sword. But if somebody wanted a duel to the death, that would be fine too. He'd use his wooden sword. You know, so he got so good that people could be attacking him with the finest weapons of the day, and he'd defend himself with something he'd carved from a tree branch 10 minutes earlier. You know? So what I'm trying to say is maybe in programming, what we should be doing is forgetting about the latest and greatest thing and just trying to do Java really well, or do C# really well, or C++ really well, or whatever. Because, as you know, vendors are constantly throwing new things at us. There's always something interesting and shiny out there, you know. But maybe, as in the Soviet army, it takes more courage to kind of stand your ground and say, nope, that's not for us, that's not interesting. What we should really be doing is profiling our code, experimenting with the data structures that we use, you know, doing the best we can possibly do with the tools that we have at the minute. You know, maybe that's what maybe that's what we should be doing. It would certainly save you a fortune in training and consultancy. Right. Let's just forget about that slide, Shad. Yeah, I'm taking that out. Yeah. So yeah, that won't be in the video. You can do functional programming in any language at all. And if you're in any way interested in linguistics, you'll know that one of the biggest debates in linguistics is, does language matter? In other words, is there something that can only be said in one language, you know, and can't be expressed in any other? And as I understand it, in the beginning people started out saying yes, you know, in each language there are certain things that can't be expressed, you know, in any other one. And then people went to the exact opposite extreme and said no, all languages are equivalent. And then they went back the other way and said no, there are certain things, you know, that your language is uniquely good at expressing. Yeah. So two very good books here I've been reading. This one is great. One of the points it makes is that if your language doesn't have a particular word for a colour, you don't see that colour, yeah? Or rather, you see what's coming in through your eyes, but you don't differentiate it from other colours, you know? And people across history speaking different languages just haven't seen colours that we would recognise today, yeah? And vice versa because of it. If you want an example that's slightly less abstract, here's another one here. One of my friends, he trained as a translator, and this is one of the examples that they always use of a good translation. In the beginning, there was this film, and in the original Spanish, the title was just Tie Me, okay, which wasn't particularly good. But whenever they translated it into English, they took advantage of the phrase that English has the phrases tie me up and tie me down, yeah, which mean almost the same but not exactly the same, okay? And that translation, yeah, made for a really good movie title, yeah? So, slightly dodgy example, you know, but it brings across the point that in programming languages, there are certain things that certain languages are good at doing. You know, you can do O and C if you really want to, okay? But certain languages are particularly good at doing certain things. Right, so of all the languages coming out at the minute, I like Scala, yeah? And I've liked Scala ever since I read that you could do this, and I didn't believe what they were saying it meant, so I wrote this, and then I ran it through the Java decompiler, and this is what came out. Yeah. Because what Scala lets you do is remove huge amounts of boilerplate, okay? So let's say I write this here. Well, what the Scala compiler says is it says, okay, you want a class called employee. You want that class called employee to have 3 fields. And you see here I've used val, yeah, that means I want the fields to be final, okay? If I'd used var, well, then they wouldn't have been. And it says, okay, if your class is going to have these 3 fields, then obviously you're going to want a constructor. So it will go out and write the constructor for you. And it will say, right, these are fields, they're read-only, but presumably you want accessors, so it'll go out and write accessor methods as well. And instead of calling them get name, get age, and get salary, it'll just call them name, age, and salary. But for interoperability, you can get it to call them get name, get age, and get salary if that's what you want. Okay? So whenever I saw this for the first time, my reaction was, wow. So I've been a huge fan of Scala ever since. Yeah. But it's only the functional bits of Scala that we'll be talking about tonight. But there's lots and lots of goodness there. Okay. So if you're interested, now's a particularly good time to be playing with Scala, because there's a company built around Scala called TypeSafe, and they've just released the TypeSafe stack, which is kind of like the Scala SDK. So it's a one-stop shop for everything you're going to need. Yeah. So you can just get it, install it. And then I recommend IntelliJ. You'll see all this code samples I'm going to do in Scala are done in IntelliJ. It is an absolutely brilliant Scala plugin that does just about everything you could possibly ask. So get the free version of IntelliJ, install the TypeSafe stack, install the Scala plugin, and boom, off you go. And if you're looking for a good guide to how you should be using Scala, Twitter use Scala, and they released this a couple of weeks ago, which is just their webpage where they've published their own coding guidelines, for using Scala. Yeah? So that's a very good resource. Even if you're completely new to the language, it's just worth reading through it, because it'll give you a good overview of what you can do. But if you're coming from a kind of Java, C#y type background, you'll probably be able to make sense of the Scala syntax. So let's look at something a little bit more obvious, a little less obvious even. And this is Clojure. Okay, so Clojure is the other big functional language arriving on the JVM. Okay, and this is a Lisp, which will cause some people to go yay, and other people to run screaming from the room. Anybody exposed to Lisp at college? Yeah, a few people. Good. Yeah. So it's a great language, and let me just show you a demo. Don't worry, I've got this in big in a second. Yeah, but if you want to play with Clojure again, I recommend IntelliJ. They're really good. They've got the Clojure plugin, which again does syntax highlighting and just about everything you need when you get started. And again, just download the free version of IntelliJ and just download the Clojure plugin, and you're good to go. Yeah, Clojure itself just basically comes as a jar file. Yeah, and IntelliJ will actually download it for you. Yay. So for everybody in the first 3 or 4 rows, you're looking at this and you're probably thinking one thing, which is, what the hell is it that sucked all the parentheses to the left? Okay, because the first thing that gets you about Clojure is the syntax. Okay, so here is it bigified. Yeah. So I should have said this is my standard demo. So anytime I start a new programming language, this is the first thing I write. So little program that says enter the height of the pyramid, you type in a number, vroom, it prints the pyramid of that height. Okay, so it's just a little bit more complex than Hello World. There's a little bit of I/O, there's a little bit of calculation, there's a little bit of iteration. Get you started. So what we've got here is we're defining 2 functions. So defn defines a function. So there's one called print row, of course, and one called print pyramid. We'll get to those in a second. But then down here, if you like, is the main. Okay, so Clojure. It was created from Lisp, and in Lisp most things are lists. This is a list here, but what we're actually doing, of course, is calling printline, which you're well familiar with, but this parentheses is kind of moved over. And then we're going to call readline, again, that parentheses moved over. And then whatever comes back from readline, we're going to feed into good old integer parseInt, so there's your interoperability with Java. And then whatever comes back from that, we're going to feed into print pyramid. Okay. So what does print pyramid do? Well, print pyramid's just a function, and it takes a single parameter called height. And what are we doing here? Well, we're calling doTimes. So what doTimes does is you give it 2 inputs. So the first input is the name of a variable. And I shouldn't say variable, but never mind. The second input, is the number of times that you want do times to iterate. Okay? So what it's going to do is it's going to run the expression on the right height times. Okay? And each time it runs the expression on the right, n will be set to the number of the iteration. Yeah? So if height is 7, it will run this bit here 7 times, and n will go from 0 to 6. Everybody okay with that? Right? So then, what we're going to do in here, well, we're going to call print row, and instead of saying n plus 1, we say plus n1. Okay? And what do we do in print row? Well, same kind of thing again. We're taking 2 parameters, the row number and the total height, and then I'm calling do times again, and then I'm calculating the right number of spaces to print out, and I'm calculating the right number of hashes to print out. And then, of course, taking a new line. But now, you can start seeing here why this way of doing the parentheses actually makes sense. Because what I want to do is to get the number of hashes, I want to multiply the row number by 2 and then take off 1. But because of the way it's written, there's no ambiguity, about what order it's going to happen in. Okay? So in list, and therefore in closure, everything's a list, and it takes a while for you to get used to that. It takes a while for you to see through the parentheses, okay? But once your eye sees through it, and it's a huge help if you've got a good editor like IntelliJ, once your eye sees through it, it's really, really neat, okay? And it has one massive advantage, which anybody who's done Lisp will know, which is that it's homo-iconic. Okay? What the hell does that mean? Well, let's just see what a non-homo-iconic language looks like. Java, for example. Okay? So this is an annotation processor. Anybody ever written one of these? Yep, good. Yep. So this came in Java 6. Let's say you want to extend the Java language. Well, you can't, okay? Unless you work for Sun now or But what you can do as of Java 6 is you can write your own annotations, and you can write a compiler plugin that processes those annotations. Okay, that's an annotation processor. So you can go out and create your own annotation, call it thread-safe or something like that, and you can use it in your code. And then you can write an annotation processor and register it with the compiler. So what happens is the compiler is compiling your code. It meets some code that's been decorated with your annotation. It goes out and creates an instance of your annotation processor and calls into it. Okay? And then whatever happens next is up to you. Because inside here you have the ability to access the syntax tree that got created by the compiler. And you can wander around the syntax tree and change things and make additions and so on. Okay? So I tried to do it, and I came to the conclusion it's bloody complicated. Okay? So writing the annotation processor itself, not so hard. Understanding the syntax tree, incredibly difficult. Because last time I checked, it wasn't well documented. And just because you know the Java language doesn't mean you can understand the syntax tree. Okay? The syntax of the language, and the syntax tree are two separate things. But if you're working in a language that's homo-iconic, well then, whenever you're writing the program, you're also writing the syntax tree, okay? They're the same thing, okay? So, as you're writing a Lisp program, you're also creating the syntax tree for the program, And, pardon me. That's why the syntax can look a little bit weird, okay? But it has massive advantages, because what you can do is you can just go out and add new keywords to the language, okay? And those are known as macros, So you see here this thing, do times, It's not a built-in function, it's not a keyword of the language, it's a macro. So in a Lisp-like language, you can, if you like, define new keywords, macros, So you can say to the Clojure compiler, right, whenever you see this keyword, call into my code, and I will give you back something that you can recognize, okay? So let's say you wanted something like do times. but instead of going from 0 to 6, it went from 1 to 7. You could write it. Yeah. Or let's say you wanted to do R times, do it in reverse. Go down from 6 to 0 or whatever. You could do it. Yeah. So in Java, there's a huge, massive difference, between writing a Java program, and extending the Java language. They're two completely different things, okay? Whereas in Clojure, they're almost identical. Yeah. As you know, there's this mad interest in domain-specific languages at the moment, which is where you go out and create your own mini special-purpose limited programming language for doing some kind of special task. Yeah. But that's a difficult, hard thing, if you're trying to do it in Java. Yeah. In Clojure, you do it every day. So in Clojure, writing code and creating a domain-specific language, pretty much one and the same. Everybody get the idea? So, very, very interesting. Okay. So, of course, we haven't got time to go into it in any more detail than that, but I thoroughly recommend this presentation here, which you can get off InfoQ. Goes into huge amounts of details about what Clojure is, what a DSL is, how you can use one to create the other. Very interesting. Yay. So, that's us started talking about the languages. Yeah, let's start talking about what functional programming actually is. Yeah. So you remember that little quiz I gave you? Anybody care to take a swing at it? Anybody care to tell me how they'd approach it in FP-like terms? Are we going to be brave? Never mind. Yeah. Let me just show you my solution. This is it in NetBeans, but this is it bigified, for the people at the back. So. What I've got is I've got this little function called check form. Okay, so when somebody tries to submit the form, this is what will get triggered. Okay, and then I've written a little CSS selector. Okay, so this is a little query, and I'm saying, okay, what I want is go to the current page and give me the form element whose ID is the form. Yeah, and then go in there and give me all the inputs of type text. Okay, so give me all the text boxes in the form called the form. Okay, and then I'm using JavaScript, but I'm also using Dojo. As you know, these days you don't use JavaScript without using some kind of JavaScript library. And the two big ones are jQuery and Dojo. So I favour Dojo. No big fan. So I'm saying Dojo.query. And what that does is that takes my little query, all the text boxes inside the form called the form, and it runs the query and returns a list of nodes. Okay? But then I want to take that list of nodes and I want to separate it. Okay? So I want to take the list of nodes and eliminate all of those that are non-empty, first of all, and then eliminate all of those that are empty. So you see here, I've got two functions, and it's obvious what they do, and I'm using those to filter the list of nodes. Okay? So I started out calling dojo.query, and that gave me a list of all the inputs of type text. Yeah, I've now filtered that list, so I've got back a list of all the input boxes that are empty, and a list of all the ones that have something in it. And that's good enough for the minute. Everybody okay with that? Cool. So if we've got one or more empty boxes, well then stop the event. Don't submit the form, don't go any further. And then what I want to do is I want to turn the labels red. Okay? So what I need to do is jump from an empty text box, to the corresponding label. And that's the hard bit. How am I going to do that? Well, what I'm going to do is call map. So map takes a list of 3 things in, let's say, and it gives you a list of 3 things out. But let's say the input, is a list of 3 A's. You get back a list of 3 B's. So whenever you call map, you pass in a function. And its job is to turn the A's into B's. In other words, I'm passing in this function F3. And what its job is to do is to take an input and give me the label associated with that input. Okay? So we'll worry about exactly how it does that in just a minute. But what F3 does is you give it a text box and it will give me the label associated with that text box. Everybody okay so far? Yeah. So these two lists here will be the lists of the labels, associated with the inputs. And then, nice little bit of Dojo. I can just go to each of those and say add class or remove class, and it'll add on or remove a particular CSS class, And the CSS class here is empty, of course, and that just says, okay, anything that's empty should have a font color of red. Okay. So the final bit, how does F3 work? Well, remember the input will be a text box. So what I want to do is I want to run another query, and my query is just span. Okay, so if I ran it without that bit there, it would give me all the span elements in the entire document. Okay, but what I'm doing is I'm saying, okay, give me all the span elements inside this bit here. Okay, so by default, whenever you run a query, it runs over the entire document. Okay, but what you can do is you can run a query and you can say relative to this node here. So give me all the elements called span, but within this part of the tree. Okay, and I'm going up to the parent of the text box, because remember, each text box is inside its own paragraph. Okay, so I'll get back a node list, of all the spans which are children of the parent of the text box. And there should only be one of those. So I select it, and off we go. Everybody okay with that? Yeah. Great. So what makes this functional? Well, first of all, I'm doing functional composition. In functional programming, you build things with functions. So no big thing. You do this all the time. So we've got A calling B, calling C, and so on. No big thing. Next one, though, immutable state. Okay, I'm not actually changing anything. Okay, so all of these lists I created, I built other lists based on top of them and so on, but I never actually changed anything. Okay, so if this was a statically typed language and I declared everything as being final and so on, it would still have worked just fine. Next thing, first-class functions. So in JavaScript, functions are first-class citizens. So you can have a function outside of an object. Actually, you can't, but don't worry about that. But you can have functions that appear to be outside of objects. And you can pass them around. So a function can be passed into another function. A function can be created inside another function. And so on. So that's a huge part of functional programming, as we'll see. Internal iteration, I'm not looping, okay? So there's looping going on. So whenever I say filter and map and so on, well, there's iteration going on, but it's going on inside the filter method or inside the map method, okay? So I'm not manually iterating, the iteration is being done for me. My code has a declarative feel, okay? I'm asking for things to be done, okay? I don't care about how they're actually accomplished, okay? So in theory, at least, I could call filter or map, and that operation could be spread out on all the cores, available on this piece of hardware, and I wouldn't know or care. Well, I might care, it might speed things up, but I wouldn't need to know about it. So the iteration is happening internally. My code is a declarative field. I'm asking for things to be done. And if you put those two together, that means that the library can do smart things under the hood, like concurrency, and I don't necessarily need to worry about the details. And then the final thing, I'm using a domain-specific language. That's the CSS selectors bit, So in functional programming, they love their domain-specific languages. Is that okay? Yeah. So we're using a language that a lot of you guys use every day, but we've used some of the main principles of functional programming already. What we're doing FP. Yeah. Grand. This would have looked an awful lot better in Dart. Anybody looked at or played with Dart? A little bit? Yeah, so as you know, Dart is Google's replacement language for JavaScript, okay? So I wouldn't need to do the Dojo bit, because what I can do is I can run my CSS selectors, and then I can say .foreach, .filter, .map, and so on, and it'll just work. Or rather, I tried to do it, and dot filter through an uncaught exception, because they haven't implemented it yet. So that's as far as that demo went. Okay, but excuse me. It would have been really nice if I'd done a full version of this in Dart. Yeah, but as of 2 days ago, Google released a version of Chrome with the Dart language built in. So you can download a version of Dart that compiles to JavaScript. The IDE is based around Eclipse. That's it there. Yeah, but you can also get a version of Chrome that now runs it natively. So very interesting. And there's a lot of good functional stuff built in there. So you're already doing functional programming. If you do XSLT, anybody do XSLT? Yay, grand. My favourite language. Love XSLT the best. Yeah. So XSLT was designed from scratch to be a functional thing. Yeah. JavaScript, as you've just seen. C#, as we'll see in a bit. Java, if you're using various libraries, you may well already be doing functional programming. You just don't know about it. Okay. So I'm sure most people will know what XSLT does. If you don't, XSLT takes in some XML and transforms it into some other kind of XML or HTML. Yeah? So you write an XSLT style sheet, and it's filled with rules called templates. Yeah? And each template has a match, which specifies which bit of the input it matches against, and then it pushes things into the output. So I was taught XSLT by a very smart guy, who hopefully we might get here to do a presentation, but that's another story. And whenever he was teaching it to me, he said, look, it's got nothing to do with files. Okay? All an XSLT engine does is it takes in 2 trees of nodes. Yeah? The first tree of nodes is your document. The second tree of nodes is your style sheet. Yeah? And it produces a tree of nodes, and that's the output. Okay? So the input document and the style sheet, well, they're probably coming from flat files, but that's not for XSLT to know. And the output tree of nodes, well, that's probably being sent over the network or saved to a file, but that's not for XSLT to know. So in the essence of XSLT is this engine, and it just accepts 2 trees of nodes and produces a third. And that's it. Yeah, and that's very typical of what people do in functional programming. Yeah, the metaphor for functional programming is that you build machinery. Okay, and the machinery takes inputs and produces outputs. Okay, and where those inputs and outputs come from, it really doesn't care about. Okay, so another example of that kind of thing. Anybody done LINQ in C#? Yay? Yeah, specifically LINQ to SQL. Anybody? Yeah, sitting with the same people, good. So what you can do in LINQ to SQL, well, first of all, LINQ is Microsoft doing Lord of the Rings. It's one query language to rule them all. So LINQ is a single query language syntax that you can use to search an XML document or a tree of objects or a database or whatever. So what I've done here is I've got a database called CoursesDB, and it holds information about training courses. And then in Visual Studio, I dragged and dropped on some tables. So I dragged on a table called Courses, it created a class called Course. I dragged on a table called Deliveries, it created a class called Delivery, and so on. And then what I can do is I can write my query using the LINQ syntax, and here it is there, so fairly self-explanatory. And what I get back is a list of course objects. Yeah, so one course object for each course where there are some deliveries scheduled. So that's LINQ to SQL, in 30 seconds. And the interesting thing about LINQ to SQL, as far as we're concerned, is it's a piece of machinery. Okay, so whenever the C# compiler gets a LINQ query in, it produces a data structure called an expression tree. Okay, and what happens after that? Well, C# doesn't really care. Yeah, it gets passed to a plugin, yeah, provided by your database, and that takes this expression tree and turns it into something that can be run against the database. Okay, but all the C# compiler does is take in the query, wherever it came from, it was a stream of characters, I assume, and then produces this expression tree, and off you go. Everybody get the idea? Yeah. So again, as with XSLT, you're building machinery. So what I've been trying to convince you there is there's a whole pile of functional stuff going on at the minute, even if you don't think of it like that. Okay? So that's kind of the first part of the presentation. for the second and last bit, let's just walk through formally all the different features that you get from a functional programming language. Okay, and I've tried to classify them from the really, really simple, to the very, very scary. Okay, so let's start with the one that everybody knows: first-class functions. Yeah. So in functional programming, functions are always first-class citizens. There's this famous blog post here, Execution in the Kingdom of Nouns. Anybody read this one? Yeah, grand? Yeah. So if you haven't, I encourage you to read it. Yeah. Even though I despise it and disagree with everything said in just about every sentence, yeah, it's still wonderful to read. Yeah. Because it makes the point that in Java you have classes and objects. You know, those are the nouns, the things. Yeah. And then you have methods, those are the verbs, yeah, and the methods are in chains, you know, they're locked up, yeah, because you can't have a method outside of its object, yeah, and that's what you have all the time in functional languages, yeah. So in functional languages, functions are first-class citizens, yeah. So not going to go into this demo in a lot of detail, but we've already seen that in JavaScript, you know, you have what they call anonymous functions. You can just say function, parameters, body, and off you go. Yeah? And libraries like jQuery and Dojo and so on, they take advantage of that. You know, we've just seen a demo. And languages like CoffeeScript, which compile to JavaScript, they give you a much nicer syntax, you know, but it's the same thing going on underneath the hood. Okay? And that's the way link is implemented. Okay? So you see here, let's say you write this link query. So what we have here is a list of employee objects. So test data is a list of employee objects, and we want every employee, call it E, where the department of E is IT, and then from that employee object we want to select the name. Okay? So the input is test data, a list of employee objects. What we're getting back is a list of strings. Okay? Well, link is actually implemented using first-class functions, yeah, or as we'll call them from now on, lambda expressions. So you see here, this is a lambda, a little bit of code that you can pass as a parameter. Okay? So whenever the C# compiler sees this, it rewrites it as that. Yeah? So we're going to the list of employee objects called test data, and we're calling the where function. Okay? So the where function requires an input, and that input needs to be a function that returns true or false, you know, a predicate. Yeah? And we could use a normal function that we had lying around, or we can use an anonymous function. We can use a lambda. Yeah? So you see here I'm saying, okay, give me all the E's where E.department equals IT. Yeah? So we'll get back our filtered list, and then on that filtered list, yeah, we're going to do what you call a projection, you know, in SQL terms. Yeah, we're going to say, okay, for each employee object, just lift out the employee's name. Yeah, so our result will be a list of strings. Okay. So as of Visual Studio 2008, yeah, C# has lambda expressions, you know, and these are functions as first-class citizens. Okay? And they were necessary in order to implement link. Okay, and normally this is the way you do link, you know, but officially link has two syntaxes. Yeah, the query language syntax, the fluent syntax, you know, as some people call it. Yeah, and then this syntax down here, where you're actually calling the methods directly and building the lambdas yourself. That makes sense? Okay. Yeah. So that's first-class functions in C#. Here's a demo from Scala, same kind of thing. So you see here, I create a variable called limit, which is 6, and then I say 1 to limit. Yeah, well, what does that do? Well, that builds a range object. Okay, so 1 to limit will build a range object that represents the numbers 1 to 6. Yeah, and then I'm saying for each of those numbers, execute this lambda expression here. So we're saying, okay, call the number num, and then just print it out. Okay, so I don't want to dwell on this because I know you can't see it at the back, but what you get printed out is just the numbers 1 to 6. Okay, so Scala, being a functional language, or a language that supports functional constructs, you know, it's got lambda expressions built in from day one. Okay. You see here this parameter called num. If you don't feel like giving your parameter a name, you can just use the underscore instead. Okay? So another example here, fold left. What does this do? Well, it adds up all the numbers in the list plus 1,000. Yeah? Or to be a little bit more precise, you call fold left and you pass in a lambda that takes two parameters, a and b. Okay? So the first time it gets called, a will be 1,000 and b will be 10. Okay? So you'll get back 1,010. Yeah? And 1,010 then becomes the a for the second call to the lambda. So b will be 11, so you'll get 1,021. Yeah? And then 1,021 will be the a for the third call to the lambda, and you'll be passing in 12 for b, and so on. So you'll end up adding up all the numbers in the list to 1,000, and that will be the result that you get back. Okay? But let's say you didn't feel like all that typing. Yeah. Well, you could just say underscore plus underscore. Because in Scala, whenever you provide a lambda, the first time you use an underscore, the compiler assumes that you want to insert the value of the first parameter there. The second time you use an underscore, it assumes you want to insert the value of the second parameter there, and so on. And finally, to see why this is really, really useful, have a look at this one here. So here's some data. Here's a regular expression, or rather, here's a string. But if I say .r, on the string, then that turns it into a regular expression object. And what I want to do is I want to call replace all in. So what replace all in does is it takes some text, and it takes a lambda that describes what you want to do with each match. Okay? So you see here my regular expression, my pattern is A to Z3. So I'm going to match against sequences of 3 lowercase letters. Yeah? And for each of those, what am I going to replace them with? Well, that's determined by the lambda. So for each match, I'm just going to convert it to uppercase. Everybody get the idea? Yeah. Great. Or one last one, closure. Yeah. So here's functions as first-class citizens in closure. Okay. So the first thing I'm doing is defining a vector, and that's just a Java vector underneath the hood, and you can see what's in it there. And then I'm calling map and filter, which we've already met. Okay. So what am I doing here? Well, I'm saying map times 2 my vector. Well, we know what my vector is. What's times 2? Oh, it's just a little function that takes x and returns x times 2, or times x2, I should say, because I'm doing closure. Yeah. So result 1 will be a vector containing 20, 24, 28, and so on. If I didn't feel like writing a little function called times 2, I could define in a function on the fly like this. So this one here is the closure syntax for creating an anonymous function. And so it's fn to say build me a function. It's a function that takes a parameter called x and returns x times 2. And if even that is too much typing for you, well, you can cut it down like this. So here's, if you like, the lambda syntax. Yeah. So I'm defining an anonymous subroutine, and I'm saying multiply %1, the value of the first parameter, yeah, by 2. Everybody okay with that? Great. So in a functional programming language, you have functions as first-class citizens. Yeah. And even C++ is now in the act. Okay? So I don't want to go through this in detail, but as of last year, a new version of the C++ spec came out, and it supports lambda expressions as well. Yeah? So C++ is now more functional than Java. Weird. Yeah? So the thing that I find weirdest about all of this, yeah, is they actually considered doing this back in 1996. Yeah? Anybody here ever heard of or program in J++? Yeah, it's just a couple. Yeah. So this was the forerunner to C#. Yeah. So right from the beginning, prior to C# and J++, Microsoft was always going to put into their language functions as first-class citizens. And they called them delegates. At the time. Yeah. And the good people at JavaSoft, they kind of threw their teddy bear in the corner about this, and they said, look, this is a terrible, terrible idea. Anything you can do with delegates, you can do with inner classes instead. Well, maybe in theory, but in practice, as you know, it leads to some really, really horrible code, with creating anonymous inner classes and that kind of thing, But they actually thought about going down this route in '96 and then turned the other way instead, which is weird, given that, to the best of my knowledge, a lot of the people who were involved in the development of Java were like Lisp, very, 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 very sharp Lisp people, and were well aware of all the wonderful things that you could do. But I think at the time, the focus was on making Java the best possible pure OO language it could possibly be. And also, I think you have to say they really underestimated the importance of GUIs. But that's a feature of Unix people anyway. Grant. But they're going to be in Java 8, eventually. Having said they'd be in Java 7 and all the hoo-ha about that, if you were following it, there was an awful lot of hoo-ha there. But they'll be in Java 8. And it doesn't matter if you can't read this, but this is the email that came out on the September the 8th, 2011, announcing that the syntax for lambdas in Java 7 would be the same as C# and Scala. Okay? So everything we've talked about, you will be able to do in Java 8. Okay? So let's just look forward to some of the wonderful things you'll be able to do. Who in here does Hibernate? Grand, quite a few. Anybody use Hibernate with Spring? Smaller number? Yep, still a few. Yeah. So you see here, let's say we're using this thing called Hibernate. And what it does is, I'm sure you'll have heard, it takes data out of objects, and pushes them into the database for you. And it can go the other way as well. So the Spring framework has this little helper class called Hibernate template. And what you do is you call one of the methods of the Hibernate template, and you specify a job of work, and it performs this job of work inside a Hibernate session. Okay, so the session object is the main object in Hibernate. Okay, so what you do is you say template dot something, and pass in an object that represents the job of work you want to perform in Hibernate. Okay? So this object that represents the job of work, well, it must be of a type which implements the interface Hibernate callback. And from that you get the method called do in Hibernate, and in there you actually put your work. So you can do it, but you can see the amount of code that needs to be written. So if you could do that with a lambda, it would just look like that. So we call execute find, as it is in this case, and we pass in a lambda that took a single parameter, call it s, and that would be your session object, and then off you go, do your job of work. Something a little bit less obscure. Let's say you're doing a swing GUI, and you're doing some work in a separate thread, and you want to pass that job of work back to swing. Okay? Well, as you know, the way that you do that is say swing utilities dot invoke later and pass in a runnable object, and that has a run method, and you put your job of work in there. Well, it'll just collapse down to that. So much, much neater. Everybody okay with that? And with first-class functions, you have internal iteration. Okay? And with internal iteration, you can do really neat things. So Microsoft have introduced what's called the parallel patterns library. So very simply, you can say parallel.forEach and pass in something iterable, some kind of list and a lambda that represents a job of work, and the lambda is executed on each item in the list. Okay, but you don't iterate over the list sequentially, it gets spread out over all the available cores. Okay? So you can see just from the output here, if you're in the first few rows, that the AB gets done, but then KL and QR and so on, they get done before EF. So the jobs of work are being spread out over the cores. Or you can take a link query, and I know you can't see this at the back, but all you need to know is you have your link query and you add in as parallel, and that's it, and then your query is spread out over the available CPUs. Or let's say you're doing some Scala and you're using the map function, that we've already discussed, but as of the latest version of Scala, instead of saying original data.map lambda, you say original data.par.map lambda, and then again, it gets done in parallel over the available cores. Okay? So with first-class functions, you have internal iteration. Yeah? With internal iteration, you can give people concurrency, yeah, without having to get them to manually worry about the number of cores or start and stop tasks or whatever it happens to be. Yeah? And that's a very interesting thing. Okay? Next one is probably the most important one for FP, and that's referential transparency. And there's a little joke that you're supposed to tell at this point, yeah, which is a programmer looks at that and goes, yep, fair enough. A mathematician goes, violates the laws of the universe. You know? Yeah. So, it works, grand. I have to put that one in again. Yeah. So, if you have some code which is referentially transparent, what does that mean? Well, if you look at this code here, classic two-string method of class person, and we're using a salary object, yeah, and you can see here what we're doing. So we're calling salary, calculate the monthly basic salary, and then give me the monthly tax amount and the monthly pension and so on. Well, if your program is referentially transparent, what you can do is you can take every function call and replace it with the result of that call, yeah, without having any effect on the rest of the program. Yeah? In other words, all your functions do is take inputs and produce outputs, yeah, but without any side effects. Okay? So let's say we take this code, yeah, and we replace this line here with the value that it would return in this case, 5,000, yeah, and then we run the code again. What happens? Yeah. Well, if we get the same output, yeah, then this code is referentially transparent. Okay. But let's say we get this here. Whoops. Yeah. So what's presumably happened is whenever you call calc monthly basic, yeah, it has a side effect. Yeah. It goes to the salary object and it stores inside fields, let's say, the tax amount and the pension amount. Okay. So your calc monthly basic function is not referentially transparent, yeah, because it has a side effect. Everybody okay with that? Yeah. So this is the kind of thing we do all the time. We write code that has side effects. Yeah. But code that's written to have no side effects whatsoever is referentially transparent. Okay. So what's the point? Well, if you write code which is referentially transparent, it's easier to reason about, yeah, simply because you can think about each function in isolation, okay? You get a concurrency benefit as well. XSLT is referentially transparent, okay? And that means that you can take an XSLT engine and make it multi-threaded, yeah, and it'll accept any XSLT style sheet and work the same as before and so on, yeah? So, as far as I know, Haskell is the only language that's completely referentially transparent, and that lets them do really interesting things. Yeah. So you're all familiar with lazy evaluation whenever it comes to ifs, with ands and ors. Yeah. But look at this one here. Let's say we've got func, which calls A and B, and if Z, then we use A in here. Well, let's say we call func. And we're going to initialize A by calling foo and B by calling bar and so on. So in any other language, foo and bar would get called immediately, before we enter the call to func. Yeah? But if you're using a programming language that's fully referentially transparent, well then you can say there aren't any side effects. Yeah? So we're going to postpone calling foo until A is used for the first time. Yeah? We're going to postpone calling bar until B is used for the first time. Yeah? And of course that gives you all kinds of optimizations and so on. Okay? But just be aware, if your program is completely referentially transparent, yeah, then all you can do is heat up the CPU. Okay? But this whole threading thing is one of the reasons people are started getting interested in this, because let me just ask you a question. Yeah, what happens if you get stabbed and you're wearing a bulletproof vest? You're wearing a bulletproof vest and you get stabbed. What happens? You die. Yes, in all likelihood. Yeah, because the knife, yeah, goes through the weave of the bulletproof vest. Okay, just because a vest is bulletproof doesn't mean it's stab-proof. Okay, there are special vests that are both bulletproof and stab-proof. There are vests that are stab-proof and not bulletproof, and so on. Yeah, and well, fascinating bit of knowledge. No, but the reason I tell you that is if you think about OO, whenever we moved inside virtual machines, we were told that the virtual machine is a big, pink, fluffy blanket, okay? Or, if you program in C++, it's a padded cell that you can't get out of, okay? Depending on which one you like, okay? But that only applies to OO. That only applies to encapsulation and so on. Yeah. So you've got all these checks that are being done to make sure that encapsulation gets preserved, and private means private, and all that kind of thing. Yeah. But threading will go into your object like a knife through a bulletproof vest. Okay. So the mechanisms that we have in OO, they don't protect you against all the terrors, associated with parallel programming and multi-threaded programming and so on. Okay? So objects and threads don't get on. Okay? So that's why there's all this interest now about referential transparency. Yeah? Because, as one of the guys who invented Haskell says, just because you have a pure language, one that's referentially transparent, that doesn't automatically mean you can take your code, and split it up into parallel units and run it, and that will result in massive performance benefits and so on. But it kind of puts you in the ballpark, if you see what I mean. So, functions as first-class citizens, referential transparency, those are the big ones, okay? Just to summarise the rest, functions can build functions. Yeah, I had a demo of that, but don't worry. But inside one function, you can go out and create another function. Another characteristic of functional programming languages is type inference. Yeah? In other words, the compiler is doing a hell of a lot more work for you. And C# does this as a Visual Studio 2008. So you can say var obj1 equals datetime.now, and obj1 is of type datetime. You can say var obj2 equals abcdef, and obj2 is automatically of type string, and so on. Yeah, so it's still strongly typed, but that strong typing is being inferred for you by the compiler. Yay. Another thing that's very important, in functional programming languages, we do our looping through recursion. Yeah? But if you program in Java or C# or anything like that, you'll have at some point written a recursive function that blew up the call stack. Okay? And the reason for that is you're only allowed so many frames on the call stack, of course. Yeah? And that number is hardwired in Java. Well, functional programming languages have a little optimization called tail recursion. Just out of curiosity, who's heard of this before? Oh, just about everybody. Yeah, very good. Yeah. So for the ones who haven't, if the last thing you do in your recursive function is recurse, now it doesn't have to be the last thing physically in the function, but it's the last thing that logically happens. Yeah. Well then, there's nothing after the recursive call. So what you can do is, instead of creating multiple frames on the call stack, you can just keep reusing that same frame. Okay? So that means you can write recursive functions that recurse 100,000 or 100 million times and don't blow up the call stack. So 2 left, and then we're done. Functional languages give you pattern matching. Okay, and this is actually probably my favourite thing about functional languages. Here's an example from Scala. Let's say we've got a class called stock item, and inheriting from that we've got book, movie, and CD. Yeah, so I've written a function called process items that takes an item, and then you can see here the choices we're making. So we're saying, okay, if this stock item is actually a book, and don't worry about the title, but if it's in the category of crime, then go off and do this. If it's actually a movie, and don't worry about the title of the movie, but it's in the DVD format, do this. If it's a CD, and don't worry about the album title or the artist, but if it's got 12 tracks, do this. If it's a CD, and don't worry about the title or the number of tracks, but it's by Soundgarden, do this. If it's a book of any title in any category, do this. Otherwise, do the other thing. Okay? So whenever you go back to Java and you have to write a switch statement, you kind of cry quietly. So pattern matching is a really, really nice feature. Okay? And then final one, and we're done. And here you have to ramp up the fear all the way. Monads. All I'm going to say of this is you do not need to care. Okay? Yeah. To do it by metaphor, yeah. Whenever I was a C programmer, fresh from university, and had to write some multi-threading code for the first time in P threads, yeah, I saw this and it scared the shit out of me. Pardon the French. Yeah, I had. This is how you go out and create a thread, yeah, using the P threads library, yeah, and I had a very nebulous understanding of pointers and so on, and it freaked me out totally. But once I got it into my head what a callback was, and why you needed callbacks, and what event-driven programming was, and so on, and once I got into my head what a void star was, and what function pointers were in general, I looked at this one day and suddenly it made sense. Okay, so monads are like that. Okay, they're nothing like pthread create, but the idea is the same. So. Monads are a design pattern used heavily in functional languages, okay? And as with all design patterns, you can use a version of the pattern that's built into your language, yeah, without having any clue that it's actually an instance of that pattern, okay? So if you use functional programming languages for long enough, yeah, eventually you'll keep hearing this idea of monads, yeah, but at the beginning you don't need to worry, okay? It's just a design pattern, yeah, that's implemented in all functional programming languages, yeah? And if your language has it built in, you can do really, really neat things with it, okay? But whenever you're just starting out, you don't need to know. Okay, so I did throw in an example, yeah, but we don't have the time. But if you're interested, come up to me after we've finished, yeah, and I'll walk you through it. So hopefully that all makes sense, yeah. So that's a really high-speed guide to functional programming. Best thing I ever heard about FP was this little quote here. In OO, we try and simplify our job by encapsulating things. We're all familiar with that. Yeah. In FP, we try and simplify things by cutting down on the number of moving parts. Yeah. And there's no reason, yeah, why you can't do both at the same time. Okay. So I recommend you get familiar with the FP parts of your own language, whether it's JavaScript or C#, or whatever. Yeah. Start using internal iteration, where it makes sense. Get used to doing things that way. Yeah. Play with making sections of your code side effect free, again, if it makes sense, and see if that makes them more testable and so on. Yeah. Once you get into FP a bit more, try with this metaphor of machines. Consider part of your application as being a machine that's referentially transparent. Yeah. And if you want to do things in parallel, if there's an opportunity to introduce concurrency, give these hands-free concurrency mechanisms that are coming through Go. So have a look at Parallel Link and mycollection.power and Scala and all that kind of thing. And as was said in the last presentation, don't take anything at face value. Okay? So measure, see if it's doing you any good, evaluate, adjust, and so on. And if you're one of these people who believe the advice of the gurus, when you learn a new language every year, well, try and make this year's new language an FP1. Okay? So Scala will take what you know and gradually, lead you down the road into more and more FP. Yeah? Or if you want to jump in at the deep end, yeah, Clojure, F#, or for the very, very brave, Haskell. Yeah? That makes sense, okay? Yeah. Brilliant. That's my show. Thank you very much indeed. Yeah. Any questions? Yeah. Any questions at all? Everybody scared? Yeah. Okay. So if there is anything you'd like to ask, please come up to me at the end. Yeah. So just before we finish, we just have two little announcements. So if I can just hand you back.
Oh. Yeah, great. Yeah, so we just show hands and appreciate for Gareth again. And just do a few trailers for what's coming up. So you've probably all seen this. We've got Kevin Henny coming, and that's going to be in the Black Box next month. So that should be good. And we are planning one more event before the summer. We don't know when, we don't know who yet, but I'm assured that it's going to be something great, so you look forward to that. And then we have a booking for September for Jim Weber, so that must be good. And yeah, and that's it. So thanks all for coming, and hope to see you in the next one.
Yeah, thank you very much.